Hot day? Why, Justin? The heat expands the air. Okay, well, here's all you have to have on your paper today. The focus, the problem, and the conclusion. And don't forget this universal law, which affects your lives in a lot of ways, including the ways I just talked about. Okay, that's the end of this focus. Today's focus is called Volcano 2. You had Volcano 1 previously. The problem is the same as for Volcano 1. Why does the red rise but the green not rise? I have 3 different liquids here, red, green, and colorless. And I'm going to put the red and the green in the colorless. And then I'll take out the stoppers, and you'll see that the red rises like a volcano, but the green doesn't. Okay. So the problem to be solved is why does the red rise and the green not rise? Okay, raise your hand if you can tell me something about the density of the red. Who can tell me something about the density of the red? Jason?
Less dense than the fearless. I mean the
Colorless. Okay. How does he know? How does he know that the red is less dense than the colorless? How does he know that, Jessica?
Because it's rising.
Because it's rising. Okay, you learned that less dense things rise in the very first focus in the program. Okay, so I'm going to put that in the form of a question. Is the red less dense than the colorless? Yes. All right, now the next question will be, is the green more dense than the colorless? Raise your hand if you think the green is more dense than the colorless. All right, about half of you have your hands up. Actually, you can't tell. Does anybody know why you can't tell whether the green is more dense? What is it about the focus that prohibits you from telling that the green is more dense, Emily?
Well, it's not out of the bottle.
It's in the bottle. It's trapped by the bottle. So we have to do an experiment to find out if the green is more dense. Now, who remembers what word an experimentation question always starts with? Jeremy? If you, now, who can tell me what experiment we can do to find out whether the green is more dense? What can we do, Emily H?
If you pour out some of the green into the colorless.
If you pour out the green, will it sink? All right, I can do that quite easily. Watch now when I pour the green out. Does it sink?
Yes.
Is it more dense than the colorless?
Yes.
How do you know it's more dense than the colorless, Wyatt? Because it sinks, okay. So, the answer to both of those questions is yes. Does it sink? Yes. Is it more dense? Yes. All right. Now, so, I can write over here as a tentative conclusion, because the red is less dense than the colorless, but the green is more dense than the colorless. Okay. Now that's reliable. We call it reliable because it's supported by the data and it's not refuted by the data. But what doesn't it tell us that we need to know? What doesn't that conclusion tell us that we need to know? Anybody? Do you think you know what it doesn't tell us that we need to know? Okay, Jeremy?
It doesn't say what the manipulated variable is yet.
Okay, good. I wasn't expecting those terms, but that's good. Emily?
It doesn't tell us how to set it up.
It doesn't tell you how to set it up. Emily H., were you going to say anything else?
How to set it up.
Okay, well, it doesn't tell you why the red is less dense and the green is more dense. So what do we need to find out? What's something we need to find out about this focus in order to come up with a complete conclusion? Kendall? Right. What's a question that could be asked? What's a question that could be asked at this point that would help find the manipulated variable? One question, Emily.
Does the red contain any water?
Okay, that's a good simple way to start. Does the red contain any water? Yes, it does. All right, who can tell me the control question for number 4? Control, Barbie. Does the green contain any water? Yes. All right. Now, ordinarily when we get to this point in a focus, the next question would be, does the red contain only water? Why don't you have to ask that question? Why don't you have to ask whether the red contains only water, Mason? Because it's red, okay. If your water comes out of your faucet that color, you better call the health department right away. All right, so, 6. Does the red contain blank, any blank? Yes. Raise your hand if you're almost sure you know something that's in the red beside water. Stevie?
Food coloring?
Does the red contain any food coloring? Yes. All right. Now, somebody that hasn't participated yet, tell me the control question for 6. Control, Jackie.
Does the green contain any color food coloring?
Yes. All right. Next question. 8. Does the red contain blank, 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 blank food coloring and water? Raise your hand if you think you know what 4-letter word goes in those 4 blanks. Jake, yes?
Soap?
What did you say, Jake? I didn't hear what you said. Soap?
Yeah. Soap.
Justin?
Only.
Only. Justin learned a long time ago about that. Word only. Does the red contain only food coloring and water? Yes. Now, who can tell me the control question for 8? Control, somebody. Everybody ought to know how to ask a control question. What's the control question for 8, Mason? Does the green contain only food coloring and water? Yes. Well, they both contain only food coloring and water. So, here's a possible explanation for that. Maybe red food coloring is less dense than green food coloring. That's a possibility. So, what experiment should we do? What experiment can we do with the food coloring to find out whether it's the red food coloring that's make this one rise? What experiment could we do with the food coloring, Emily?
If you have a little thing of food coloring,
Right, but what's something else we could do, Stevie?
Turn the red upside down and see if the red's
Oh, well, we know it's rising, so we know it's less dense. What experiment could we do with the food coloring, Jonathan?
switch spots.
Switch them. If you put green food coloring in the right-hand bottle, will it still rise? All right, now who can tell me how to word the opposite experiment? Tell me how to word the opposite experiment, Darby.
the green food coloring doesn't rise.
How would we word the opposite experiment? Let's begin with if you.
If you put red food coloring in the left-hand bottle,
Good. It'll still sink. All right. Now that's a pretty complicated set of experiments. So I'm gonna review it for you. What we're gonna do. You have to imagine this now because it's too difficult to do it physically. All right. We're going to imagine that we start over with the same three liquids, except there's no food coloring in them. Same three liquids, but no food coloring. All right. Instead of putting red in here, we're going to put green in here. The question is, will it still rise? Yes, it will still rise. Instead of putting green in here, we're going to put red in here. The question is, will it still sink? Yes. So this one will rise with either the red or the green. This one will sink with either the red or the green. What does that prove about the food coloring? Who can figure out what that proves about the food coloring? Wyatt? They're the same density. Right. So it's not the food coloring that's making the red less dense and the green more dense. Allie? You got a question?
does red and green have different types of water?
Well, let's pursue that. Well, before we pursue that, let's pursue the part of the focus we don't know anything about. Which part of the focus don't we know anything about yet, Brandon?
I got two things.
No, I want to know which part of the focus we don't know anything about yet. Who knows that? What don't we know anything about yet, Jeremy? Well, no, okay. What part of the focus we don't know anything about yet? We know what's in the red. We know what's in the green. What don't we know? What don't we know, Mason? Okay. 12. Does the colorless contain any blank? Yes. All right, here's a clue about something that's in the colorless. It's a substance that we program our space probes to look for on other planets. What do we program to look for? Water. Okay, so there's water in the colorless. Now we have to answer this question. And I'm going to ask somebody to give the answer to this question, somebody that hasn't participated yet. Does the colorless contain blank, 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 blank water? What's a word that fits in the four-letter blank, four blanks? Name one thing, Nathan.
Only.
only water. Yes. So look, this is getting more puzzling all the time because the colorless is only water. We found out that the food coloring doesn't matter, and the red is only food coloring and water, and the green is only food coloring and water. So essentially, all three are just water. The red is just water, and the green is just water if we ignore the food coloring, and the colorless is just water. All right. But we know that the red is less dense and the green is more dense. Now, how can you have nothing but water in three containers and have them be different in some way? Who can name one way that that could happen, Jackie, or Jessica?
Different kinds of water.
The same kind of water. In fact, here's something important. I got the water for these three containers out of the same faucet. How can you get water for three containers out of the same faucet and have them be different in some way? Emily?
What you do is you boil it, and then you have that ice,
Oh, you're talking about distilling.
yeah.
No. Well, it's a lot simpler than that. Who knows how you can get three containers of water out of the same faucet and have them be different in some way? Some way, Darby. Temperature. Okay, I'm going to write 3 questions on the board, and I'm going to see who can fill in the blanks. Is the red blank? Yes. Is the colorless blank? Yes. 16. Is the green blank? Yes. All right, now, here are the 3 words that go in the 3 blanks. Hot, cold, and medium. Now, who can tell the class what medium means? When you say something's medium, what does that mean about it? What does that mean about something that is medium, Janelle? Huh? Well, okay, what's another way of putting it? If we're talking not just about temperatures, but anything that's medium, what does it mean if it's medium, Stevie?
A little bit like
Okay, Kendall? In between. Medium comes from Latin, means middle. Okay, now, raise your hand if you can tell me which of these words goes in blank 14. Which word goes in blank 14, Joey?
Hot.
Raise your hand if you can tell me which word goes in blank 15. Jonathan?
Cold.
Raise your hand. I'm going to pick somebody that hasn't participated yet to tell me what goes in blank 16. Somebody that hasn't participated yet.